Good morning students. Today our topic is temperature sensor. So this is the temperature sensor. Before going to temperature sensor, so first we have to know what is meant by temperature. Temperature is a thermal state of a body. It is nothing but the thermal state of a body which determines whether the body is hot or cold. So the temperature is the thermal state of a body which determines whether the body is hot or cold. So when the substance which give out heat, it becomes cool, or if the substance receive heat from the other body, it becomes hot. So that's why the temperature determines whether the body is hot or cold. And heat always flows from high temperature body to low temperature body. The instruments for measuring temperature are categorized in the following classes according to the principle of operation of the instruments. So here are so many instruments which are all used to measure the temperature. All are categorized according to the principle of operation of the instruments. So depending upon thermal expansion. So when we heat the materials are expands. That expansion is called thermal expansion. So depending upon thermal expansion, so there are so many types of thermometers: bimetallic thermometer, liquid and gas thermometer, pressure thermometer. So come to our topic, which is nothing but bimetallic sensor. So this is a temperature sensor which is called a bimetallic sensor. So this is a bimetallic strip. So here we are taking two different materials. One is the brass, another one is the steel. So here these two are different materials are joined together. This is called a bimetallic strip. So this is known as a bimetallic strip. Here two different materials are joined together, and these two materials having different thermal expansions or different thermal coefficients of expansions. So two dissimilar metals having different thermal expansions are joined together. That is known as a bimetallic strip. So under normal temperature, that means at room temperature, the bimetallic strips is straight or flat. When it is heated, the bimetallic strip bends. So that means here we get a convex shape when it is heated. That means which possess high coefficient of expansion, that material bends towards the low coefficient of expansion side. When it is cold, we get this shape, concave shape. So using this bimetallic strip, we can measure the temperature, or we can sense the temperature variation in any instrument. So come to bimetallic strip. It is based on the principle that if two strips of different metals are joined together, here two strips of different materials are joined together, then with the change in temperature applied, it causes bend in the bimetallic strip. Change in temperature means it may be cooled or heat, then the bimetallic strip bends. Okay. So when the bimetallic strip is heated, that means we are changing the temperature from normal to high temperature. Or when it is cooled, that means we are changing the temperature from normal to another temperature. Then in these two cases, the bimetallic strip bends. So that is the principle behind the bimetallic sensor. So using this principle, we can sense the temperature variation at any place. So by calibrating the magnitude of the bending, so by calibrating the amount of bending with respect to temperature change, the bimetallic strip can be used as a thermometer or sensor. Okay, clear? So here two dissimilar metals having different coefficients of expansion are joined together, that is called a bimetallic strip. Under normal temperature condition, it always flat and straight. When the temperature changes, that means normal to high temperature or normal to low temperature. That means when it is heated or cooled, the bimetallic strip bends depending upon amount of bending. That is the magnitude of bending. With respect to temperature change, we can use this bimetallic strip as a sensor or thermometer. Two metals with different coefficients of expansion are connected together, forming a bimetallic strip unit. So the strip remains flat and straight at the room temperature at which metal pieces are bonded. So come to our sensing condition. When the strip is heated to the high temperature, the strip bends towards a metal side having low coefficient of thermal expansion. So this is the bimetallic strip. When it is heated, then it bends, the bimetallic strip bends. So the in that which is having high temperature coefficient of expansion, high coefficient of expansion, that bends towards the low coefficient of thermal expansion side. The metal with higher coefficient is called active side, while the metal with lower coefficient side is called passive side. Here this is the active side and this is the passive side. The displacement of the free end, so this is the actual position of bimetallic strip when it is in straight. When the strip is heated, it bends. So this is the displacement from actual position. So by calibrating this displacement, we can estimate the temperature. So the displacement of the free end can be converted into an electrical signal. So already I told that sensor only senses or detects or responds. After then, that signal is converted into electrical signal using a transducers. Here also in bimetallic sensor, here the variation, displacement variation indicates there is a change in temperature that is sensed by the bimetallic sensor, and this displacement is converted into electrical signal using secondary transducers like variable resistance or inductance or capacitance transducers. So using any one of the resistance or inductance or capacitance transducers, we convert the output signal into electrical signal. Here the displacement from the fixed position to bended position, this displacement variation senses the temperature variation, and this amount of displacement is converted into electrical signals using secondary transducers. So this is about temperature sensor. It is very easy and very applicable.